Alright guys, I'm going to do some graphing of sine and cosine, and we will do some transformations of these as well. These are our last two parent functions that we learned in this course, and they will be on your exam in the transformations section. We talked about in class that sine is actually a function, and cosine can also be graphed as a function. And we're going to essentially use these kind of sides of our quadrant graph, so 0, 90, 180, 270, 360, from that cast graph. But this time, all we need to do is enter in these values into our calculator. So you actually don't even have to memorize these points. As long as you know 0, 90, 180, 270, 360, you can go then in your calculator and enter in sine 0, press equal, you'll get 0. Sine 90, press equal, you'll get 1. Sine 180 will give you 0 in your calculator, sine 270, a negative 1, and sine of 360, not 1, sorry, just kidding, 0. Okay, and cosine is similar, so we'll use the same x values, except for they will give us different y values. So cosine 0 will give us 1, cosine 90 gives us 0, cos 180 gives us a negative 1, 270, 0, and 360, 1. Okay, 0 and 360 are always the same because they're actually the same position on the cast graph. Okay, so you should know that those will always give you the same values. Even when you transform them, you'll have the same y values for those two things. Okay, same position equals same y value. Okay, so when we go to actually graph these two things, we'll do that on the next page, we get to periodic graphs. Alright, here we go. I'm going to graph sine in red, and I'm also going to show you how to graph it, extend the cycle backwards as well. So our first point was 0, 0, 90, 1, 180, 0, 270, negative 1, and 360, 0. So there's our points. Here's the first little section of sine. That wasn't good, sorry. Okay, and I'm going to teach you how to extend it backwards, and essentially what we're going to do is we're going to kind of follow along with these points, and we're going to go backwards because we're extending backwards, right? So we're going to go backwards from the 0 point, and that's going to go down 90 degrees to negative 1, okay, which is here. Now we just did this point right here, so we're going to go back up, and as we go back up, we are going to go up to 180, 0. Okay, then we continue along our pathway here, up to 270, 0. Okay, and then down to 0. So that's what we get. Okay, so that is sine extended in the negative direction. Okay, I'm just going to erase these. Alright. Okay, let's do cosine now. Cosine, let's do that in blue. I'm going to start with 0, 1, 90, 0, 180, negative 1, 270, 0, and 360, 1. Here's our first little section here. Okay, not perfect, but close. Okay, and we're going to do a similar thing. So we will start at this top negative 1 point, and we're going to extend backwards. So as we extend backwards here, we're going to go to this point down here. So this point, if we extend backwards 90 degrees, it's going to go down to 0, just like this one did. Okay, those 2 points are the same. Okay, then we're going to extend downward again. Let's use a yellow here. Okay, downwards again, that goes down to negative 1. So down negative 1 and 90 degrees. Okay, moving again to our next point here, this yellow point. If we go 90 degrees over, we go up to 0. So 90 degrees over and up to 0. And lastly, up to our ending point here. So over 90 degrees and up to 1. So this gives us this graph here. Okay, so this is our cos x graph, And here's our sine x graph. Okay, it's important to know that you should always be going mountain, valley, mountain, valley, mountain, valley. So if you end up with 2 mountains in a row, that's going to be an issue. Okay, this is a mountain right here, and this is a valley right here. Okay, so we're going to take a look at a transformation of sine. And there's a couple things first that I want you to notice about this function. This is the a value, but it also tells us that the amplitude of our function is 2, meaning that the distance from the center to the top of a mountain is 2, and the distance from the center to the bottom of a valley is also 2. So the entire height of our graph is going to be 4. Okay, the next thing that I want you to notice is this 3 here. This tells us the number of cycles that fit between 0 and 360. And we can also find the period of our function by doing 360 over the k value, which is 3. And it ends up telling us that it takes 120 degrees for one complete cycle to finish. Okay, we also know that this has a phase shift 30 to the right and a vertical shift up 1. Okay, this is also the center of our graph. Okay, meaning that basically if I had the center of my graph and I went up the amplitude from that, which is 2, I'd get my max, which will be 3. And if I went down 2 from that, I would get my min, which would be -1. Okay, now to the transformation part of this. My parent function is sine x because of this sine right here. So we're going to start with the key points of sine. Okay, and then we're going to do some transformations to those. So I want to identify a, k, d, and c. So here's my a, and here's my c. This goes into the ay plus c section of our transformations. So a times y plus c. And we're going to do the reciprocal of k and the opposite sign of d. So I'm going to get 1/3 times x plus 30. We're going to take a second to calculate each of these values from our parent function values. Okay, so here are my values. You're going to notice, just like we said over here, that my max is 3 and my min is -1. So that prediction is helpful for us to see in our transformations here. You're also going to notice something cool about the x's, which is that they have to be consistently spaced because these are consistently spaced as well. So you're going to actually notice a pattern with the x's in our transform function, just like the x's in our parent function. And what we're doing is we're adding 30. So this is nice because it allows us to extend for additional values if we'd like to keep going on our graph. So if I keep adding 30 and I keep repeating these y values, I can actually extend as many cycles as I want. Okay, so for instance, let me extend 1 for you here quickly. We can add 30 once, we'll get 210. And after 1, we get -1. So -1, I'll add 30 again, I'll get 240. And after -1 comes 1. Add 1 again, get 270. After 1 comes 3. And one more time, we get 300. And after 3 comes 1 again. We can keep repeating that cycle. It's also sometimes helpful to see what the 0 starting point is. So going back from 1, we get 3. Okay, so let's go ahead and graph this. Okay, so I'm just going to graph one cycle of my parent function. We're going to say, based on what we need to accommodate here, this can be 1, 2, and 3, and -1, -2, and -3. Okay, so here's my parent function. I'm just doing one cycle Okay, so there's sine x. Now we're going to do our second function here. And I'm just going to graph all of these points. So let's start with 0, 3. Then 31. 60, negative 1. 91. 123. 151. 180, negative 1. 210, 1. 240, 3. 271. And I think we went up to 300, so 300, negative 1. All right, so there's our function.